So our next champion in that story is Galileo Galilei, Italian. Now he lived in Florence some of his time, uh, and what's interesting for us is that he was the first person to point a telescope to the heavens, to the sky, and made a number of observations. And we're going to see that these were instrumental in actually killing geocentrism. He didn't die instantly, right? I mean, at some point you probably heard about the story that he was condemned by the church because he said that the earth was rotating, etc. So again, parallax was not there yet, but you're going to see that there were extremely compelling arguments, ones that impacted the philosophy behind the geocentric model, and that suddenly some of the arguments didn't make sense anymore. And philosophical arguments, and there were already evidences that pointed to the fact that few things couldn't be explained except by heliocentrism. Now, recall the date of his death, 1642. There is something I like about, one quote I like a lot about Galileo, and it's basically the one written here, which is basically saying that if God created reason, why would he at some point tell me not to use it? I mean, for him, reason was telling me that the earth is moving around the sun. Everything is pointing in that direction. So why should I forego the use of my reason and just continue to say that the earth is fixed at the center? The other interesting thing is that he worked a lot on physics. I mean, it was not called physics at the time. So he was trying to investigate motion of objects, understanding the laws of these motions. And that's extremely important for one step later, as we're going to see. Again, remember the date of his death, 1642. So that's Galileo's telescope. It was a tiny telescope. It was 2.6 centimeters in diameter, the lens. Tiny, tiny. Today, if you buy any telescope, the smallest you'd buy is probably 5 centimeters for diameter. And yet he did a huge amount of things. One of the few things he discovered is the fact that there are spots on the sun. Well, the sun was God. Perfection. Spots on God? Philosophical argument. So suddenly, things were not as interesting as they used to be. He looked at Jupiter. And that's one of the killer arguments. Now, if you look at that manuscript in the hand of Galileo, let me show you a few things you'd see there. So if I choose a pen, and if you look at these things, this, and this, and this, and this, and this, and that. I mean, you see the same pattern repeating many places, right? And there's something here, 4 stelle, 4 stars. Okay, so what Galileo saw is actually 4 stars that were always close to Jupiter. But not only that, if you look at these diagrams, I mean, that's just one page. If you look at all the other pages, he did notice that these stars were actually changing position around Jupiter. And changing position at some point periodically. He was able to measure the time they take to basically go back and forth between those positions. And he rightfully thought that these were moons of Jupiter. So he already saw Jupiter as a disk. We're going to see it in the next slide. But the more important part is that he actually discovered that something was moving not around the Earth, but around something else. And one argument about the fact that how would the moon be able to follow the Earth? And then suddenly something else was not just carrying things orbiting around it, but if the moon was the only object moving around the Earth, something had 4 things moving around it. So it was mightier than the Earth, if you'd like. Again, philosophical argument, probably you'd say. But they were compelling because, I mean, all that maintaining of geocentricity was solely based on philosophical religious arguments, and these were basically crumbling one after the other. But we're still no killer argument. Actually, the moons of Jupiter do have a killer argument. I'm not going to go into it. Very briefly, at some point, the timing of the eclipses of the moons of Jupiter ended up being used as a timing device. So you had tables on which you knew when the eclipse would happen, and carrying those tables around the Earth would help you actually determine longitudes, because a clock would help you determine longitudes. But the more important part is that at some point, to have accurate tables, Galileo discovered that the only way to have these accurate tables is to take into account also motion for the Earth. If you didn't take into account the fact that the Earth was moving, there was a creeping error that went into the eclipses and actually went slowly with time. Because as the Earth moves, you'd see the eclipse happening at different times. Think of it as some kind of parallax of the eclipse. So anyway, that's an argument you're not going to find on websites. It's a complex, tiny argument. You might see it if you go to Florence and visit the Galileo Galilei Museum. You're going to see a timing device for the eclipses. He actually built a small device with moving objects, and you could actually get see the orbits of the moons of Jupiter and when they eclipsed, but it used to take into account the actually moving Earth. So that's one argument. The second one is by looking at the planets, he did discover that, well, suddenly it's not just the moon and the sun that are disks. Every other planet is a disk. So every other planet is similar to the Earth too, and similar to the moon and the sun. He even saw almost the rings of Saturn. Saturn is the left-hand upper corner. That's Saturn. I mean, that's a symbol for Saturn also. You're going to see it in old manuscripts. You're going to see those symbols repeating. And you have the impression that you have some kind of two handles on the two sides. So he did see the rings of Saturn with his tiny telescope. That's Jupiter at the center. And the one to the utmost right upper corner is Mars, the symbol. But the interesting one is the one below, Venus. And he saw phases for Venus. Now, phases, as we understand them for the moon, and they understood them for the moon, were actually due to the illumination of the sun on the planet. And so he saw that Venus appeared as a crescent and a large one. So it was close to Earth. And it appeared almost full as a small disk. So it was far from Earth. And the minute you put them in a diagram, if you assume heliocentricity, perfectly explained. Now, obviously, the question is, how would they appear if we were in the geocentric model? And that's what I'm going to ask you to try to find out and compare in an assignment what you'd see for the heliocentric model and what you see for the geocentric model, and compare to Galileo's observations that we've just seen, and decide for yourself which one is the correct model. So that's going to be a very interesting point you'll need to look at. Okay. Other things he did, as I said, other than the famous telescope and astronomy, he was working, as I said, on free fall and ballistics, so on the motion of objects. And it is said that had he communicated with Kepler, they might have actually beaten Newton. Now, Newton was not alive at the time, but they could have found the laws of gravity before Newton. So the thing that actually brought him into trouble is the dialogue of two worlds, which is right in the center. Now, what actually made him avoid problems initially was the fact that he was friends with the Pope of the time. He was real friends before he became Pope, when he was a cardinal. And then when the guy became a Pope, he was quite lenient until at some point that book came out. Now, the book had two problems. One of them was the fact that it was published in Italian. Now, you might think, wait a minute, he's Italian. Why would he not publish in Italian? Well, because at the time, the same thing that's happening today in universities, we publish in English today. At the time, the language of learned people was Latin, and Italian was the commoner language. So writing in Italian, you make a book available to everyone. And moreover, in the book, he was actually making a discussion between, in a way, geocentricity and heliocentricity. And the representative of geocentricity was called Simplicio, simple-minded person. And the Pope thought that he was talking about him, that Simplicio was actually the Pope. So imagine the consequences. Anyway, the story set aside, with Galileo, we began to have those killer arguments that were actually making the edifice of the philosophical edifice of heliocentricity crumble down. We had a killer argument now with phases of Venus, with the moons of Jupiter orbiting around Jupiter, and with the timings of the moons of Jupiter. And if I go back to Kepler, what we finished with, at some point when people started calculating predictions with Kepler's orbits, well, predictions were far beyond the precision of what Copernicus could do with his model, or Ptolemy could do with his model. So a lot of arguments were suddenly there to say, make do with geocentricity. Now we're going to see the one that finished it all forever and no one talked about it anymore. So we're going to stop the story, and the story will continue with a title that's slightly different. The title is called Gravity, not the movie.